Find the resultant of two forces, one with magnitude 155 pounds and direction of 50 degrees west of north, and the second with magnitude 305 pounds and direction of 55 degrees west of south. Okay, so again, what you want to do, you want to draw a picture. So I'm going to first start with the vertical line. And this vertical line will be important because it serves to tell you where the north is going to be and where the south is going to be, right? We know that the north is up and south we know is down, okay? So from there we can start to build our angles. So the first one that you should take a look at is 50 degrees west of north. West meaning that we're going this way, right? So west is going to be pointing left, okay? So that means we start at the north and then we make a 50-degree angle pointing towards west, right? 50 degrees west of north. So that means we're making this angle pretty much. And don't measure it with a protractor because I'm not drawing this to scale. I'm just drawing a reasonable 50-degree angle as best as I can. Okay, so this will be 50 degrees. And now the second angle is going to be 55 degrees west of south, right? So the south is here going down. So 55 degrees from there is going to be where we need to have another angle drawn, right? 55s will be a little bit bigger than this. So again, don't judge how I do this. And keep in mind that the magnitude is greater. It's 305, right? So this definitely should look longer as a vector than the previous one, right? So this is going to be this one. This is going to be this one. And this measure is 55. Okay? So now that we have that, you realize that in order to find the resultant vector, we're going to have to be talking about a parallelogram. Okay, so basically you can trace a vector parallel to this green vector by simply making a parallelogram like this. Okay, and also trace this vector so that it's going to be parallel to the opposite side of this parallelogram, just like this. And again, don't judge how I do it. It may not look like a completely fine, 100% accurate looking parallelogram. That's not the point I'm trying to make, right? So, so there are two ways of getting the resultant vector. The first thing you should realize is that to get the resultant vector, you can add this vector and this vector, right? And the resultant vector will be simply this vector, right? That arrives at that same final point. Okay? So, right? So it arrives at that point. So you can either start adding from this one and then add that one, or you can start adding from this one and then add the second one. In any case, these two, the opposite sides, will have the same magnitude. They will have the same length. This parallelogram will have opposite sides being equal, basically. Okay? So, opposite sides are equal in a parallelogram, and also the opposite angles are equal as well, right? So we can label this angle theta, and this is angle theta. Now keep in mind that this pair of opposite angles is also going to be equal. Okay, this one, and this one, right? They will be equal in measure. And notice that we can actually find the measure of that. If I label this parallelogram as A, B, C, D, A, B, C, and D, we can find the measure of BAD. The measure of BAD is actually going to be found by subtracting 50 and 55 from 180. Okay? So 180 minus 50 and 55. And what does that give us? 180 minus 105, which gives you 75 degrees, right? So this is 75 degrees. So we can label it as 75 degrees, right? 75 degrees. So now that's 75 degrees, we know this one also must be 75 degrees because the opposite angles in the parallelogram are going to be the same in measure. And now it remains to find theta. So realize once again that there are two forces, right? This is the first force, and I'm gonna show you that it's actually magnitude, not just a force, but it's also a magnitude, is 155. Okay, and the second one is 305, right? So we can think of it as this force, F2, which is 305. Okay, so basically, as you can see, we can find the resultant force by relating these three sides, basically the resultant force side, the first force side, and the second force side, with the theta using the law of cosines. Okay, because if we know this angle theta, we can find the resultant force using the law of cosine. So how do we find this theta? Very easily, right? So theta is equal to what? Now I know that the interior angle sum in a parallelogram will be 360 degrees. How do I know that? I know that because we have 180 n minus 2. Okay, that's the formula. N is the number of sides. In this case, n is equal to 4. Right? So if n is equal to 4, look what's going to happen. 4 sides minus 2, right? 4 minus 2. What does that give us? That gives us 180 times 2, which is equal to 360 degrees, right? So 360 is the angle sum of all 4 angles here. So that means we can find the angle theta by doing this. We subtract from 360 the sum of these two 75s, so the twice of 75, and whatever we get will be the sum of these two angles that are equal in measure. Thus, we can divide that sum to get each individual angle theta, right? Because these two are the same in measure, right? So as a result, what does that give us? That gives us 105 degrees. So the angle measure of theta is 105 degrees. So bingo. That means we can use the law of cosines because we know this side, and the theta. We only don't know the opposite side to the angle theta, right? So as a result, we can set up the law of cosines equation. Okay? So I'm going to mark it with red so that you see it's the same one. It's this vector, magnitude. So this being squared is equal to the first force squared plus the second force being squared, the magnitude, not just the force, but the magnitude of those forces, minus 2 the magnitude of F1 times the magnitude of F2 times the cosine of theta. Cosine of theta, so cosine of 105 degrees. Okay? So as a result, what you should have, if you do this right, and of course you're going to take the square root, right? So if you take the square root, your resultant force magnitude is going to be what? Should be equal to about, well, I'm not going to round it just yet because we're going to need that number, but it should give you this, 376.1932226 pounds. Now, what did we just find? We found the magnitude of the resultant vector, right? But we need to find not just the magnitude, but also the direction, right? Because each vector, when you're talking about a vector, you're talking about its magnitude plus its direction, right? There are two components to that, the direction and the magnitude. So we need to find the direction. Okay? Now, keep in mind that the resultant force, the way I drew it, will not correspond to how you would see it when it's drawn to scale. So this angle may look like it's greater than 90 degrees. It should be less than 90 degrees, the actual answer. And I'm going to show you. So again, this is not drawn to scale. Not drawn to scale. Okay? Because this is not a computerized drawing. So in any case, we need to find basically this angle measure now. This angle measure. Because the resultant force definitely comes, it comes away from the south line, right? It goes away from the south line. Okay, so we have to see how much does it waver from the south, right? How much does it go off from the south? Because this one that we already have there wavers 55 degrees west of the south, right? 55 degrees west. But the resultant force will waver even more from there, right? It will go off even more than 55 degrees. So we need to find that total angle. So what we're going to do, we're going to label this remaining angle that we need to find, because we already have 55. We need to find this one, right? The alpha. I'm going to label it alpha, just this angle here. How do we find alpha? We find the alpha by actually using the law of sines. Okay? So we have the theta, right? So we're going to use this triangle. So triangle ADC, or ACD. Let's do ACD. So triangle ACD. So law of sines for ACD. So I'm going to label this as law of cosines that we used, so that you know which formula is which. Now law of sines is for the triangle ACD. So how is the law of sines going to work out for us? So law of sines needs two angles and two sides opposite of those angles, right? We have angle theta. We have the opposite side known, right? 376.193. We know the theta is 105. We have the alpha that's unknown, but we have the known side opposite of that angle alpha, right? Because that's the second force of the first force of 155 pounds, right? This is parallel to this vector. This CD vector is parallel to AB vector. So we can actually write this as sine of theta divided by the resultant vector magnitude that we found is equal to the sine of alpha. The alpha is the one that we're trying to find, right? That we're trying to solve for in order to find the resultant vector direction, right? So that will be divided by the opposite side, which is the first force vector magnitude, right? So that's that. So now we can just substitute in the numbers and just solve for alpha. So now sine of 105 divided by 376.1932226 is equal to the sine of theta, alpha, being divided by the first force magnitude, which was what? Which was 155 pounds. So now if you do this right, cross multiplication here, you should get sine of alpha being equal to 155 sine of 105 being divided by 376. 1932226. Okay, so as a result, this calls for the arcsine function to be used, right? Because the arcsine makes sure that the sine goes away and that the alpha will be solved for, right? So as a result, the alpha is going to be the arcsine of the right side. So the arcsine of 155 sine of 105 divided by 376.1932226. Okay? So as a result, this is what? This is equal to, if you do this right in the calculator, 23.45214.578 degrees. Thus, measure of then let's label this point E. So measure of this angle that we're trying to find, CAE, is going to be what? Is going to be 23 plus 452, 14578 plus the known one, 55, which is going to be about 78 degrees, okay, if you round to the nearest whole number. Thus, the answer is going to be this, right? The resultant force is 376, and I'm rounding 376 to about 376, right? To the whole number. Nearest whole number is 376 pounds. 376 pounds in the direction of 78 degrees west of south. Okay, so I hope this was helpful and fun. Thank you so much for watching. See you in the next video.